Assalamualaikum warahmatullahi wabarakatuh, and hi. Today I would like to present to you guys about chromatography. This is my group member. First we have Haras Mubashir and Muhammad Afif Amrin, and then Muhammad Danish Martin. So what is paper chromatography? Paper chromatography is a method used in analytical chemistry to separate dissolved chemical substances by utilizing their varying rates of migration across paper sheets. There are two main components in paper chromatography, that are stationary phase, also known as water trapped in the paper or paper strip, which is made up of cellulose fibers, and others is mobile phase. Mobile phase is an organic solvent such as mixture of methanol and water. Usually, the paper chromatography is often used to separate complex mixture such as amino acid, peptide, carbohydrate, steroid, purine, and a long list of simple organic compounds. Also, paper chromatography is used widely in industry, such as in food. They are used for analysis of food color in ice cream, sweet drink, and beverage, jam, and jellies. And for forensic science, they can successfully investigate a case by using a small sample they obtain from the crime places. There are many techniques to perform a chromatography method. So in this picture show a few techniques that we learned in our syllabus.
Assalamualaikum everyone, my name is Haras Mubashir and I will continue about theory on paper chromatography. Okay everyone, the principles of paper chromatography is as below. Chromatography paper is typically made of cellulose fiber, which is a polar substance. Being polar, it has an affinity for other polar substances and can effectively interact with them during chromatographic separations. Cellulose fiber ability to trap water molecules is particularly useful in chromatography. Water is also polar, and the cellulose fiber's attraction to water helps create a suitable environment for the movement of substances in the paper. This allows for the differential movement and separation of components in a sample mixture, enhancing the chromatographic analysis process. Apart from that, in chromatography also, the compound mixture being analyzed usually contains unknown substances that require separation or analysis. Chromatographic techniques are employed to separate the different components within the mixture, allowing for their identification and further examination. Furthermore, paper chromatography is a type of partition chromatography, where a compound mixture distributes itself between a mobile phase, which is solvent, and a stationary phase, which is cellulose or chromatography paper. As the solvent moves through the paper, the components interact with the cellulose fiber at different rates based on their chemical properties. This interaction causes the components to separate from each other, creating distinct patterns on the paper. By analyzing these patterns, scientists can identify the substances present in the mixture. The separation of compound in the chromatography depends on the attraction between the compound and the solvent in the stationary phase, which is determined by their relative polarities. Polar compounds have a stronger affinity for polar solvents and the stationary phase, causing them to interact more strongly and move more slowly. On the other hand, non-polar compounds have a weaker attraction to the polar stationary phase and tend to move more quickly with the mobile phase. By adjusting the polarity of the solvent and stationary phase, scientists can manipulate the separation of compounds and achieve desired analytical results. Okay everyone, now we will continue on mobile phase and stationary phase. The first one, the mobile phase. A mixture of solvents is commonly used as a carrier for the compound mixture in chromatography. The primary role of this solvent mixture, also known as the mobile phase, is to facilitate the movement of the components along the chromatography paper. By carefully selecting and adjusting the composition of the solvent mixture, scientists can control the speed and direction of the components' migration on the paper. The mobile phase interacts with the compound mixture and carries the components as it moves through the paper, allowing for effective separation and analysis. The choice of solvent mixture is crucial in achieving optimal separation and obtaining accurate results in chromatographic techniques. Second, the stationary phase. The chromatography paper is the platform where the separation of components occurs. It is made of cellulose fibers and acts as the stationary phase. The compound mixture is applied to the paper as a mobile phase, which is the solvent, moves through it. The components migrate at different rates based on their interactions with the paper. This differential migration leads to the separation of the components. By analyzing the separated bands on the paper, scientists can identify the individual components. Essentially, the chromatography paper is crucial for facilitating the separation and analysis of the compound mixture. Okay guys, that is all from me. I will pass on to my associates, Afif.
Assalamualaikum warahmatullahi wabarakatuh, and hi, I am Muhammad Afif Amrin, and today I will share about methodology of paper chromatography. So, this is a materials and apparatus are used in paper chromatography. First is a microcapillary filter paper, color dyes blue, green, red and yellow, developing solvent, plastic wrap and beaker. This is a methodology or procedure in paper chromatography. First, prepare the paper chromatography by draw a line parallel about 2 or 3 cm from the bottom of filter paper. 2. Draw a small X on the beginning line ranged about 3 cm distant of each other and mark X with B, G, R and Y, which means blue, green, red and yellow. Then spot each of the marks with food colors using microcapillary. Number 3. Prepare the mobile phase by pouring small amount of the solvent into a clean beaker. The level of solvent should be lower than the spot in filter paper. 4. Placing the filter paper in the container with the solvent. The paper should be held in the place to avoid the paper from move. Number 5. Developing the chromatogram by allowing the solvent to move up the paper by capillary action. The solvent will carry the components of mixture along with it. Number 6. After the solvent has reached the top of the line in the paper, remove the paper into the beaker and let it dry for a few minutes. And lastly, analyzing the chromatography. The components of the mixture will appear in the filter paper. Measure the distance traveled by spot and by solvent. Then record the RF value. So, let's continue to the next topic. Bye-bye.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Dinesh Martin, and right now I will explain to you of the result and example of paper chromatography. Okay, so right now we have an example of the result of our experiment on paper chromatography. So right now at the full color we have blue, green, red and yellow full color, and each of the color, on blue they have red and blue spot, on green they have yellow and blue spot, on red they have only yellow, and on the yellow food color they have only red and yellow spot. On the spot on red color they have distance traveled by spot is 22 mm and 95 mm. On the green food color, on the blue yellow spot they have 76 and 81 distance traveled by spot. On the red they have 30 and yellow they have 11 and 69. On the distance traveled by solvent is each of them is 100. So calculation of formula for finding the RF value is distance traveled by spot divided by distance traveled by solvent front. On the food color blue, at the red spot we have 22, and divided by 100 we got 0.22. On the blue spot we got 95, and divided by 100 we got 0.95. On the food color green, at the yellow spot we got 76, and divided by 100 we got 0.76. On the blue spot color we got 81 divided by 100 we got 0.81. On the food color red, and red spot we got 30 divided by 100 we got 0.3. And the last one, at the food color yellow, on the red spot we have 11, and divided by 100 we got 0.11. And the last one, yellow spot, we got 69, divided by 100 we got 0.69. So that's the explanation on how we calculate the RF value and how the result to calculate them. Thank you.
In conclusion, paper chromatography has enormous potential and value in a variety of industries. This method is a valuable tool for separation and analysis in industrial settings due to its simplicity, cost-effectiveness, and versatility. Among other benefits, paper chromatography will likely continue to be useful and promote industrial processes and product development, with further research and technological development. Okay, that's all from us. Thank you for lending me your ear.